My name is Matt Szlazak. I'm from Raytheon, Australia. I'm joined this evening by my colleague Julian Rech, also from Raytheon, Australia, and we've been collaborating with Ebrahim from Uni in South Wales, Canberra, on this paper and another paper on the presentation, sorry, and another paper which we'll talk about. Thank you for joining us. Our topic is integrating mission engineering and model-based systems engineering using ARCADIA-Capella. So we'll talk through that. Our presentation is to do with mission engineering. Obviously, that's not the focus of today, so we'll just introduce the topic and a little bit of background on that and how we've developed mission engineering architecture meta model to enable us to digitize and model mission engineering processes. We'll then look at how we've implemented MEAM in Capella using the Arcadia method, and then a case study to do with how it was also to implement the implementing the Arcadia method to do with the microgrid scenario, and then we'll finish up with some conclusions and lessons learned. To get into the topic, so mission engineering is a methodology. For those who aren't familiar with it, it's a methodology that was developed by the US Department of Defense. Probably others have contributed that to it as well. But primarily our source has been the US Department of Defense and the Australian Department of Defense. The methodology enables, mission task groups and military formations to be and associated supporting infrastructure to be optimized to achieve an overall mission outcome. So by considering the different mission nodes as a collective system, it enables decisions to be made and optimize, the overall capability, look at the levels of effectiveness and the interoperability and all those sort of aspects from that mission-wide perspective. So primarily, we've been looking at as I mentioned, the US Department of Defense Mission Engineering Guide and the Australian, where we're from, the Joint Mission Design Guide. So last year, in September 2024, the three of us developed a paper and presented at the Systems Engineering and Test and Evaluation Conference in Melbourne. And the intent of that and the purpose of that was to show how mission engineering can integrate with systems architecture and systems engineering to create mission aware systems. So we developed a meta model to support that initially in Cameo Systems Modeler, but now we've taken that and implemented that in Capella using the Arcadia method. So that's the purpose of our presentation here today. So when we talk about the mission engineering architecture meta model MEAM, this is primarily what it is here. We have some extensions to this, but this is the heart of it. So on the left, we've got three layers, if you like. The mission definition layer in the green. We then have the mission design layer, mission characterization layer in the blue, and then the mission design layer in the yellow. I will talk about how that all comes together using a mission thread model. And then the meta model itself is how we implement those threads is shown on the right there. So as mentioned, so we implemented this in Cameo Systems Modeler in an SO product. But what we really wanted to show, and I guess one of the benefits of what we're doing here today is the approach is essentially tool agnostic. If we want to federate models from different systems, different platforms, then we need to be a bit more open. We don't want to be tool locked. So that's what we're showing here today, how we can use that meta model to support a bit more of a tool agnostic approach and show the benefits of Capella and Arcadia method. So this here is the process we follow. So we've taken from the Joint Mission Design Guide and the Mission Engineering Guide, and they essentially are paper-based processes. So we needed to develop a methodology and a repeatable approach to how we can digitize these and model the scenarios. So and we'll talk through that in the case study a bit later as well. But this is the background process. In the green, we've got the mission definition layer, which we define mission scenarios. We then break that down into more specific use cases or vignettes. And that we're really just trying to establish the key operational effects and the mission outcomes at that layer. But it's a really useful medium to I guess visualize that and engage stakeholders who may not be as familiar with model-based systems engineering as well. So that's the other added benefit. We then take those use case scenarios from the green layer and develop those into the mission thread model, which you see in the blue layer. So in that thread, we're trying to establish the mission tasks and the key strategic actions that need to happen across the different platforms. Whereas I guess having said across the platforms, really solution agnostic at this stage. So we're not allocating specific tasks to specific assets at this point. We're really just trying to establish the overall sequence of events, the operational process that needs to happen. And that's what we do with the find, fix, track, target, engage, and assess process there. And then we have a feedback loop there. That's what we've used for our scenario, but it could be any, I guess, OODA loop operational process is acceptable. Sense decide effect, because the observe rate decide act OODA loop is good. It works for any of those processes. So that's the blue layer. We then take the blue layer and allocate to specific nodes or systems or platforms within the mission, depending on what level you're modeling at, and that forms the mission engineering threads for each of those assets. And what we do as part of that is we refine the role that each or the contribution that each asset makes to that overall mission. And then we're able to establish, I guess, a capability baseline for each. And that's what we see here. So for each node, system in the group, we establish a capability baseline, which we can then flow down to our model-based systems engineering activities. And what this provides is it enables, I guess, a mission perspective on those MBSE activities. So rather than just doing them in isolation, it provides that mission perspective. And that's where the ARCADIA method comes into it. So, and we'll show that in a couple of slides. So here we can see the overall approach. So we have the MEAM in the green. That's the model we developed for the mission threads. We then develop that striker capability baseline for each node or each system in the mission, and then we flow that down to the MBSE activities. And as I said, that allows us to take that broader mission perspective. We can then trade off solutions, I guess, from the overall benefit and pros and cons for the mission. Typically, if you just looked at it, that MBSE layer might be more of a cost schedule or programmatic focus. So by having that mission perspective allows us to take a broader, bit more of a balanced approach. And over on the next slide here, we can see how we actually implement that. So on the left, we've got the Capella and the Arcadia architecture hierarchy, and we've overlaid the MEAM meta model onto the top two layers. So the operational analysis and the system analysis layer, and we then flow that down into the logical and physical architecture layers, which we've retained from the Arcadia method. I'm going to hand over to Julian, who will say or discuss exactly how we've implemented that.
Sure, thanks. Thank you, Matthew. So we've got Capella here, which is hopefully very familiar to a lot of people. I'll just jump to the next slide, and what I've got on the left are the Arcadia elements and the Capella Arcadia diagrams that we've been using. And then on the right, I've got the MEAM elements, or what that maps to in our meta model when we do these mission designs. So as you can see here, a lot of the operational activities, which a lot of us will be more familiar with, when we talk in a mission context, we're talking about mission tasks, mission threads. Another example is when we talk operational or entity scenarios or activity scenarios. That's when in the mission analysis we're talking scenarios and vignettes. I won't talk to all of them, but that is for reference, this slide. Because what I'm really going to go through now over the next few slides is the problem space. So I guess the challenges or what we were trying to do with Capella. What we found is that in most SysML-based modeling tools, stereotypes can be applied to extend existing SysML elements, which is quite, I guess in some tools, quite simplistic. However, in Capella, it's managed a bit differently, which caught us a little bit off guard. There are tools such as PVMT, the PVMT add-on that I'm sure a lot of us are familiar with. However, it was quite limited for what we needed, and that's sort of where it brought us to what to do next. So solutions. we worked with Obeo, and we had sort of two reasonable solutions to go forward. The first was, I guess, what I'll call an advanced approach, which is probably to a lot of us a more standard approach, and that involved using SIRIUS and creating an add-on. So something like basic maths or the requirements viewpoint add-on, a lot of online available add-ons which we could have used. We did struggle a bit when we looked into this method. However, it's probably more suited to software developers or software engineers than ourselves, and we were looking for a solution that we could implement in a matter of weeks, something nice and easy. So what we then recommended was an expedited approach, and that's where we looked at, I guess, a quick approach, replacing the Capella icons with the relevant MEAM icons directly in the existing jar files in Capella. So it was actually very quick and a good solution. We may one day or next look at the advanced approach, but this expedited approach actually worked quite well, and we'll go through that today. How did we do that? I guess on the side of the project, we wrote a quick tool in Python. We called it the Icon Manager, and it had a few buttons. The first was to browse to find your Capella, the location of Capella installation. We were using Windows at the time. And then it was a button to install, and then a button to uninstall, so we could revert back to a base Capella and then go into a MEAM Capella. We were working with Capella 7.0.0. However, I'm sure it wouldn't be too much to implement this on more later versions. A little bit of detail for those who are interested. We had three main Python scripts we were working with. The first was we called replace icons. It was the core of the tool. You could use this independently of the others if you just wanted to go directly into Python and run the code. And it uses pandas, pretty standard Python library, as well as others, to read CSVs, and then pathlib shoutil to process the jars and move icons into the desired locations and re-zip them up. From there, we did have the UI, which was, I guess, more optional, but made it a bit more easy to work with for people who weren't as familiar with Python or a terminal, and that was mainly using Tkinter. And then finally, just for ease of moving it around, we just used PyInstaller to package it up into a single executable file so we could move it around, especially for testing and sharing amongst ourselves. And so finally for myself, once you'd installed the MEAM icons, this is sort of what Capella looked like at a glance, and Ebrahim will go into detail in a second. And as you can see, there were various changes to what people are used to seeing in Arcadia, and a lot of the buttons and terminology was more suited to the mission buttons and terminology that we were more familiar with it, and that we were trying to implement and use. So that's all from me. I'll hand over to Ebrahim now to explain the diagrams in more detail. Thanks, Ebrahim.
Thanks, Julian, and thanks, Matt, for the explanation. So as Matt and Julian explained, we are trying to close the loop between mission engineering and model-based systems engineering, and have this continuity in the digital thread between the MBSE tools, which is Capella in our case, and other tools that we can use or we will use downstream for further mission analysis and system fitness analysis for different missions. And after implementing the solution for applying the MEAM framework in Capella, we started using it for our case study. And the mission in our case study is this sustainable power integration for crisis event mission. It mainly aims at enhancing the energy resilience of at disasters and the ability to provide better response capabilities in vulnerable areas during specific disastrous events. So as with any mission engineering effort, the missions are characterized as a system of systems environments, and the systems we are contributing to our missions are listed here. We have a mobile microgrid, which is deployed to provide energy. We have a disaster alarm and monitoring satellite, which monitor the area and provide data about the progress of the disaster and the situation, and also the deployment of the microgrid. We have critical infrastructure operators, headquarters, local governments who coordinate the receiving the mobile microgrid and deploying it, national emergency management agencies, logistics and transportation systems, and energy coordination systems. Now, as part of any also mission engineering definition, when we start defining our missions, we need to define different scenarios or different vignettes which are plausible for the mission. So here we have two scenarios. One of them is where we have the microgrid is deployed as centralized hub to provide energy for the affected or critical nodes in the affected area, or we can have it as a distributed system where it's distributed across specific or different locations, deployed across these locations and nodes. And when we design the system using the model-based system engineering perspective, or have logical design, for example, or a physical design, we start comparing or doing trade analysis and mapping how the system is designed to these different scenarios, and see or measure the effectiveness or the performance of the system at these scenarios, and if the design is the amount of coverage each design is providing for the different scenarios. So then we start using Capella, and mapping it to the mission engineering activities. So we start by we start by the mission objectives, as Matt explained, and these are mapped to operational capabilities, and of course the system, which system node or which participant systems in the mission need specific operational effects, or will be directly involved in which operational effects. And we have operational activities, which are represent the mission essential tasks, or the specific tasks that need to be achieved in order to perform the mission. And then we utilize operational processes to represent the sequences of tasks that are needed for the mission, or the mission threads that are needed to achieve the mission. And of course, we link these to the specific operational capabilities or specific operational effects that need to be achieved, so we know which activities are needed for which mission effect. And then, as you can see here, we have the whole tasks needed for the mission, and we show the processes, of course, on the same diagram. This is the activity diagram in Capella, operational activities in Capella, and we also can see what are the tasks that are common between the different threads or the different processes. And of course, these represent the importance of some tasks or the criticality of some tasks for the mission. So the more involved with a certain or the more common a certain activity or task in multiple processes, we know that this is a more critical task for the mission. And then we move to the mission engineering thread, where we allocate different tasks to specific nodes or specific players or specific systems in the mission, and have a representation of our system of systems. And as you can see, we are using the architecture diagram, which is unique to Capella. So now we have a view about the tasks performed by each system, and again, which ones are more critical, depending on the criticality of the tasks that they are performing. So a very important point here is that all these diagrams are using the MEAM icons and the terminology of mission engineering, which makes it easier for mission engineers who have limited knowledge about MBSE or systems engineering in general. This enables them to use tools like Capella or any other modeling tool, and they can, at least, even if they are not using the tool, they can easily understand the artifacts that are coming from the tool, or the work that has been done by model-based systems engineers or systems engineers, and then we can have this common understanding, and we can collaborate, or they can collaborate better in mission analysis and mission design. So this is about our implementation. Now, what have we learned along this journey? So first, when we first set out to develop the plugin for our mission, we quickly realized that building custom extensions requires a deeper level of software expertise than we initially anticipated. Instead of getting bogged down by the lengthy development cycles, we decided to pivot and adopt a faster, more practical workaround, and that actually still delivered the same functionality for us without and limited the overhead that's needed for a full solution. So the main lesson here is that sometimes the most effective approach isn't the most complex one. We can find a simpler solution that enable us to have the same effect. And of course, we need to consider the limitations of expertise and time when we try to apply these solutions. The second lesson is Capella add-ins is one of its strongest feature. The ability to have or develop add-ins or add-ons that enable you to do multiple or increase the capabilities of Capella is really great, and it offers a tremendous amount of flexibility, and especially if you have the right expertise. But there is a catch, like while this customization is powerful, it also introduces complexity to your work. So the more you tailor the tool, the more you need to understand not just what you want to achieve, but how to achieve it without creating unintended challenges down the line. And this is a reminder that flexibility comes with responsibility, and finding the right balance is key to making the most out of your tool. As modern systems grow more complex, mission engineering, and as we move more toward this system of systems environment, mission engineering becomes more important and more fundamental on how we design and develop successful outcomes and capabilities. But we still have this lack in our tools, and there are still no tools, enough tools that are capable of catch up with the development of mission engineering and the need for mission engineering. So right now, tools are designed with generic workflows in mind, but we really need tools that support mission engineering or mission-oriented processes, and support also linking mission design and mission to analysis tools that enable us to do better mission analysis. Another lesson, one area Capella could really shine in is its support for stereotyping. So right now there is a clear opportunity to make advanced customization, like what we see in other tools like Cameo, when you are able to create profiles and customize your profiles. So there is a room for improvement and adding even add-ons that can handle this, or include or add capabilities like this to Capella. Another lesson, when we bring tools to new domains, like mission engineering, it's easy to make assumptions about what they can do, how they will perform. However, we must never underestimate the limitations or the possibilities of these assumptions implied by these assumptions, and overlooking these constraints can lead to frustrations and setbacks in your work. So you need to consider this carefully when you are bringing a tool to a new domain, and carefully consider what the tool can do and what are the real needs of this new domain. We have also been tempted by quick fixes. They are easy, they solve immediate problems, but this experience taught us that investing time and effort in building a good, solid solution can really pay off down the road. And even though it might take a little longer to develop the solution, the repeatability of the solution and the adaptability and reliability of your solution can really be very helpful when you try to apply it. And this is the main actually gain. One of the main gains we get by applying or using MBSE and the tools that implement MBSE is this repeatability and reliability. Whatever solution we develop shouldn't be a one-off solution that can be used one time. It should be used multiple times. Another big lesson we learned is that because we are trying to bridge the gap between two domains, MBSE and mission engineering, we faced a lot of terminology that mean the same thing in the two domains. However, they are called different names. So this highlighted the need to think about how can we find these commonalities and highlight it and show the differences in usages of terms. However, the background meaning is the same, and there is still no clear solution for this, but ontologies can be one of the solutions that enable this. So we are keen to investigate this further. Finally, to make MBSE practices truly adaptable, it's essential to distinguish between the language, the method, and the tool. So although Capella is not a mission engineering tool, because we understood the method behind Capella, which is ARCADIA, we found that this is a very helpful and useful method that we can apply for mission engineering practices, and it enables us to address many of the mission engineering design challenges, and this is why we ended up using ARCADIA, and of course the tool that comes or applies ARCADIA. But without this understanding, we might have dismissed Capella and didn't see the real value behind using it. So it's very important when you go through any application, you understand. You don't just look at the tool itself, but look at what method is applied behind the tool, and is this method really useful for your application, and how can you tweak your usage of the tool based on to benefit from the method behind it. So this concludes our presentation for today. Thank you for listening to our presentation, and thanks Matt and Julian for joining me today, and thanks Obeo for giving us this opportunity and the platform to share our work with you. We are happy to take your questions if you have any.
All right, thank you very much for this presentation. Thank you, Ebrahim, Matt, and Julian. So maybe before the first question arrives, you can give us, if you have that in mind, an idea of the size of your model. So not the exact number of Capella model elements, but maybe to give us a bit of perspective on the number, I don't know, of diagrams or elements, or the size of the model, the complexity of the model you worked on, if you have this kind of figures in mind.
So I can take this one. Again, as with any, because this is a system of systems architecture, you can expect the model to be a quite complex model because you have multiple systems, you have activities assigned to each of the systems, and it's not a trivial activity or mission that you want to achieve. So you expect to have the orders of like maybe 50 or more activities at the operational layer, and then we break these down at the system analysis layer, where we focus on the functionalities of each system, and then at the logical layer we mainly focus on our system of interest, which is the microgrid in our case, and how it interfaces with our system, how it should look like in terms of its design, logical design. And when we achieve the physical layer, when we start working on the physical layer, we start implementing this logical design, and then after that we take it to the analysis. So you should expect, if you are having, or if you are working in the domain of mission engineering, you should expect your models to be a bit more complex than the conventional models that only focus on single systems or specific systems, because now you have more systems integrated in your and included in your model.
Is there any capability of document generation from the model?
I guess that wasn't focused. So whatever's built into Capella right now, I guess the good thing about the approach we're using is we'll have a standard set of views. So if in future, we do want to generate a document suite, maybe for that capability baseline or for the system of interest output with like a design, then there'll be specific views, and that'll be the next thing, is to auto generate a lot of that out of the model. That would be the I guess the end goal to optimize the process, most definitely.
Okay, thank
And
you.
I can add that I know that there are add-ons that enable Capella to produce documents, and you can specify your template for the documents. But this wasn't actually the main purpose of us creating the model. Our main purpose was, when we have a system design, how we can use this to take it to analysis and use analysis tools and simulation tools to measure the fitness of system design to the mission, given the mission conditions and the mission characterization, and how it can collaborate properly with other systems in the mission. But this takes us back to the point I mentioned in our learned lessons, where tools like Capella are flexible, which is a good thing, that it enables you to do multiple things. So if you want to generate documents, you can install this add-on and then use it to generate documents. We didn't end up doing this because this wasn't the purpose. Again, it depends on the purpose of your model and how you want to use it, which add-ons to add, which capabilities to use. It depends on the purpose at the end of the day.
Okay, thank you very much. So what about the integration of cybersecurity missions continuously in MBSE? Any advice?
I can talk to this one. So cybersecurity, I just stepping back a little bit, mission engineering is one method of tackling a complex problem, similar to systems architecture being a method, similar to other existing cybersecurity methods. There's nothing stopping you from using a mission meta model to look at cybersecurity problem, providing you start with a mission statement, look at what all the inputs are, what your desired effects are, and go from there. However, in saying that, I guess from experience, there are probably better meta models out there, more aligned to cybersecurity, that you might want to use. And I'll also note that the tool is probably not so much the issue. Capella and other MBSE tools are excellent places to do your cybersecurity modeling, especially if they've got a SysML background. What comes to head is I know there is a CMT Australian meta model which you could potentially use, as well as other, I guess, more recognised meta models to incorporate NIST and other frameworks. Yeah, hopefully that helps with that question.
Just to finish on that, I guess a lot of the cyber evaluation management toolkit, they're very design layer focused. So one of the benefits of a mission approach is it gives you that top-down perspective, so you can then start to analyze interfaces, prioritize which links, which interfaces you want to protect and which are more vulnerable than others. So then you can really narrow in the focus on the design layer. But so that is a benefit of mission engineering, gives you a broader perspective on the whole environment. And then you use the other tools where they fit best.
So thanks for the presentation. Can you tell us more about how or if the model can be used to show trade-off between different systems when creating and evaluating multiple alternative mission engineering threads?
So yeah, this is actually the second part of our work, which we are still working on, and we didn't end up presenting today. So after having the first, as we showed in the presentation, the first two layers in Capella focus on the mission contextualization and understanding the context of the mission, the operational analysis and system analysis. Now, when we move to logical design, logical architecture, and physical architecture, we start seeing this different designs that we can do trade-offs in between. So we have starts from logical design. What are the logical components of the system? How you build the system without going into the physical implementation. And then we can take this we can have different logical designs, and then we take these different designs and feed them to simulation, and the simulation reads the model. It understands or takes all the systems participating in the model, understands we define the measures of effectiveness for the mission and the measures of success for the mission, and then we map how the different architectures enable the achievement of the mission based on the measures of success. And then we compare the fitness of these designs. So this happens outside Capella, but again, one of the values of using a tool that can interface with other tools is that you can easily grab information or fetch information from the model and use this information for further analysis downstream. So we are still working on this, but the plan is, as we are having now different designs at the logical and physical levels, we feed them to the simulator, and the simulator read the mission context, the other systems participating in the mission, the performance metrics for each of the systems, and map or measure the fitness between each design and the requirements of the mission. I hope this answers your question.
Okay.
If not, please follow up if you wish.
Do you have an estimation in comparison to your strategy versus implementing this using the SIRIUS technology, if you're familiar with that?
It's a really good question. I'd love to say we have an answer, but we didn't actually succeed in using SIRIUS. We probably spent 5 times as much time trying and didn't get anywhere. I think if we had someone to assist us, it would have maybe even been just as quick. But yeah, we ended up reverting to something a bit more simple, which took not much time at all. Hopefully that helps.
Okay, thank you very much for your presentation, for the answers to the question.